Okay, the first definition we're going to talk about is a point. A point indicates a location and has no size or dimension. The picture of a point is a dot. So you see this dot right here. And next to that dot is a capital letter. So the notation for a point, to label a point, has to be a capital letter. You can choose any capital letter from A to Z. Okay, but it has to be a capital letter with a dot next to it. This column here are examples where you would see a point in the real world. Okay, so if you've ever seen a map before, any city on a map is indicated by a point or a dot on that map to tell you where the location of that city is. So that's where you would see a point. A line. A line is a straight path that extends in two opposite directions without end. So it's a straight line, it's a straight path that goes forever in two directions. Since it goes forever in two directions, it has an infinite length, and it also has an infinite amount of points on that line. But in order to create a line to begin with, you need at least 2 points. If you have 1 point, like this point here, then when you go to draw a line, you don't know where to connect to another point to show which direction that line is going in. But if you have 2 points, like you have right here, if point A, if you start drawing a line through point A, you know the line has to go in this direction because you have to also go through point B. So you need 2 points to make a line. The notation for a line, so you notice you have your 2 points, or you have this script lowercase m up here. So one way to notate a line is you could say it's line AB, putting this symbol above. And you notice how it's got 2 arrows on either side, saying that from point A it goes forever this way, and from point B it keeps going forever that way. You can also call this line BA. So line AB and line BA are the same line. You could also call this line line M. So you use that little script M, the lowercase m, in that notation as well. Notice that you can't call this line A or line B separately because those are not script letters. Alright, where do you see a line in real life? There are lots of places. The example we have here is a line in the road. So that line in that road will forever keep going in that direction, in 2 directions. Alright, a line segment is a part of a line that consists of 2 endpoints, okay, and it has a finite length. So when we take a look at the picture, okay, it's a part of a line. So here's the line AB up here. The part of that line is this part between A and B, okay, and it has 2 endpoints. So A is one endpoint and B is the other endpoint. So it doesn't keep going past B and it doesn't keep going past A. To notate what a segment is, to name it, okay, you've got AB and you've got BA. Those are the same segment. Notice how up here, right, you had the arrows on the top. You don't have the arrows on either side because it doesn't keep going in those 2 directions. Alright, a segment in real life. The picture we have here are a bunch of logs floating in water. Each log in that water is a segment because the logs stop on either side. Alright, array. Array is a part of a line that consists of one endpoint and goes infinitely in one direction. Okay, so if we take a look at the picture, it's part of a line that consists of one endpoint. So here your endpoint's A because there's no more part of a line over here. Okay, nothing keeps going over here. It starts at A and then it goes infinitely in one direction. So the direction is towards B through point B and it keeps going through point B. Okay, the notation for array. Alright, so up here, remember, you had arrows on either side for a line. You had no arrows on either side for a segment because it stopped in either direction. And for array, you only have an arrow on one side because it starts from A and then only goes in the direction towards B. So you have to label this as ray AB. What is not allowed, okay, is ray BA. And that actually should have a ray symbol on top. But this is not a correct way to name this ray. Okay, if it started at B and then forever went in the direction towards A and this part over here wasn't there, then you can call that ray BA. Alright, where do you see a ray in real life? So here we have a lighthouse. So all of these lights coming off the lighthouse are rays because they start at the middle of the lighthouse and then forever go in that direction, forever go in this direction. So there are 4 different rays there. Alright, opposite rays. Opposite rays are 2 rays that share the same endpoint and form a line. So taking a look at that picture. Okay, so here you have 1 ray, so ignore this part right here and just look from point C. If you start at point C and forever go in this direction, that's 1 ray. Then if you start at point C and forever go in this direction towards B, ignoring this side over here, that's another ray. So 2 opposite rays in that picture are ray CA and CB. Notice how this ray starts with C, goes towards A. This ray also starts with C and goes towards B. So they have to have the same starting point. Okay, an example of real life ray. We have an intersection here. Okay, there's two pairs of opposite rays here. If you start here at the middle of the intersection and go towards this car in that direction, and then if you start from that same intersection and go towards this car, those would be 2 opposite rays. And then you would have another pair of opposite rays starting from here and going up, and from here and going down. Alright, a plane. A plane is a flat surface that extends in all directions. Any 3 points make a plane. So you only need 3 points. So you're talking about a flat surface. So if you had 3 points, if you connected those 3 points, you would make the shape called a triangle. And a triangle is a flat shape. So you only need 3 to make it. If you only had 2 points, then you wouldn't be able to actually make a shape at all, and you would have your line. So you need the 3. You can have more than 3, but you need at least 3. Okay, so here, let me fix something really quick. Okay, so here you have 3 points A, B, and C on a plane. Okay, this flat surface right here, the shape, and you have this uppercase script M. So just keep note of that. To name a plane, you can name this plane a couple of different ways. So just like we did a line before, you can call it plane M, but notice that this is a capital script M, not a lowercase. So you can name it plane M, or you can name it any 3 combinations of points on that plane. So one combination would be plane ABC. You can name it plane BAC. You can even name it plane CAB if you wanted to. You just need at least 3 points. If there was another point on here, D, then you could also name it ABCD if you wanted, but you need at least those 3 points. Alright, where do you see an example of a plane in real life? Okay, this is a ramp off a truck. Okay, this is a flat surface, and imagine it's extending in each direction for an infinite amount of time or length, and that would be your plane. Alright, collinear points are points that are on the same line. So collinear. Linear meaning line, and co meaning at least 2 on the same line. Okay, so if you look at this picture here, okay, you've got A, B, and C are all on the same line. So those are collinear points. Okay, A, B, and C are collinear. Points A, B, and D, so A, B, and D, are not collinear because they are not on the same line. However, these 3 points here would form a plane if you connected those 3 to form a triangle. Okay, so just keep that in mind for a second. So an example of collinear, alright, here you go. You've got a chessboard. Let's see if I can make this a little bit bigger. Nope, I can't. Alright, so the chessboard piece, if you just look at the three pieces, so this piece right here, this piece right here, and this piece right here are all collinear because they are on the same line. These 3 pieces right here, 1, 2, 3, are also collinear. They are on the same line. And then through any 2 points, you can draw a line as well, and those must be on there. So I could take this piece all the way up here and this piece right here and connect a line through those 2 points, and those also have to be collinear because any 2 points form a line. Okay, coplanar. So this collinear was points on the same line. Coplanar are points or lines that are on the same plane. Okay, so if you look at this picture here, okay, that looks a lot like this picture up here. So points A, B, and C are all on the same plane because they're all on plane M. Okay, all right, so points A, B, and C are all coplanar. Going back to this chessboard up here, all of these chess pieces are coplanar because they're all on the same flat chessboard. All right, so those points, all those chess pieces are all coplanar as well. All right, if you look here, so that was an example with points that are coplanar. This is an example of lines that are coplanar. If you look at this football field, all of these yellow lines are all on that same plane as well. All right, parallel lines. 2 lines that do not intersect and 2 lines that have the same slope. So the reason they don't intersect is because their slopes are the same. So if you look at these 2 parallel lines, you've got line AB, and notice I have 2 points. 2 points make a line, and I have line CD, 2 points on the line. Okay, and these 2 lines will never intersect because they're slopes. The slope of the line, the way the way the line is tilted, both of them are exactly the same angle. The angle is the same tilted. Okay. Also notice, or tilted the same. Also notice that you have these 2 arrows on this line and you have the 2 arrows on this line. This is what it means. If you see these 2 lines, then they're telling you those 2 arrows. They're telling you that those lines are parallel to one another. So that's the symbol. If you're going to tell they're parallel on a line, you draw those 2 arrows. Okay. How you would notate that these 2 lines are parallel? Line AB. So remember, you put the arrows on either side of AB, and you've got line CD, the arrows on either side, and this right here is the symbol for parallel. Okay, looks like an 11. That means that those 2 lines are parallel. Where do you see parallel lines in real life? This is an example of a railroad track. So this line right here, right, forever going in that direction, and then this one forever going this direction. These 2 lines are parallel to one another. All right, skew lines. Now this is one of the harder definitions, but skew lines are 2 lines that do not intersect. So right now, if you're thinking, well, parallel lines don't intersect, how come skew lines aren't the same as parallel lines? The other part of skew lines is they are not parallel as well. So they can't be parallel and they cannot intersect. So an example that we can look at, if you take this cube, okay, and you're looking at line AB right here, okay, and line CD right here. Well, CD and AB are definitely not parallel. This line right here and this line right here are parallel. Okay, so they can't be parallel, and then this line does not intersect this line. Line AB is skew to line CD, so there's actually no symbol for skew, so you would just write out the word skew. And the example in real life, so these are 2 street names. The street name on top is not parallel to the street name on the bottom, and those street names will never intersect one another. Okay, perpendicular lines are 2 lines that intersect at a right angle, and they're also 2 lines with slopes that are opposite reciprocals of one another. So first, let's just take a look at the picture and then talk about the slopes. Okay, so you've got line CD right here, 2 points on the line, and you've got line AB, 2 points on the line. This little box means that there's a right angle there, which is 90 degrees, and since this line and this line intersect at a 90-degree angle, those 2 lines must be perpendicular. You'll also know that these 2 slopes, okay, so this slope for parallel was the same slope as this, because they're tilted the same angle. These are not tilted the same way. This is actually the complete opposite. This horizontal line is the complete opposite of this vertical line. So that's why their slopes are opposite reciprocals. And we'll talk more about what that means as the unit goes on. Okay. So here you've got AB is perpendicular to, so this upside down T is the symbol for perpendicular. And I think I'm missing, so give me a second. There you go. Here are your two lines. Okay, so you've got line AB, okay, that's the horizontal line, and you've got line CD, which is the vertical line, and they're both perpendicular to one another. So this is the symbol for perpendicular, this is the symbol for parallel. Okay, the example of perpendicular, so you have a soccer goal, and if you look down at this corner right here, that little red is your 90-degree angle. Okay, this is one line, and this is another line going up, and since they both intersect at a 90-degree angle, those two posts of the goal must be perpendicular to one another. Alright, so now we're going to talk about, we've talked about lines, we've talked about planes, we've talked about points, so what happens when they intersect? Alright, two lines intersect. So here you've got line M, the script M right here, that's this line, and you've got line L, because it's a script L, that's this line here, and you've got point T. So these two lines are intersecting at point T. So how would we write that? Two lines intersect at a point. So this line and this line, when they intersect at a point. Here they intersect at point T. So you've got line M and line L. Keep note of the script M and the script L intersect at point T. Okay. What about two planes intersecting? So here you have your script uppercase P for a plane, and you've got your script uppercase Q for this plane. So this plane is going up and down, and this plane is going left and right, and they're intersecting. Now notice they're intersecting at this part right here. But a plane goes forever in every direction. So plane P, this plane is actually forever going this way, this way, this way, and this way. And Q is doing the same thing in all those other directions. So they're intersecting here, but since this is a line and this forever goes in one direction, this line is actually going to forever go in this direction too. So you've got two planes actually intersecting at a line. So here, plane P, okay, upper script P, and plane Q are intersecting at line AB. Since they forever go in each direction, this intersection part right here must forever go in each direction. So it must be a line that they intersect at. All right, what about a line and a plane? So here you have plane N, uppercase script N, that's this plane right here. You've got line L, all right, which is laying on the plane N. And then you have line M, which this is a little bit hard to see, but this line is going through the plane. So this line is going straight down. It hits the plane at point R, and then this part right here is dotted because you can't see that part. It's going through the plane, and then it's popping out the other side. Okay, so you've got line M, that's this line right here, intersect at plane N at point R. So so line M is a vertical line that is going through the plane. So it intersects the plane at point R. You don't see it right here, that's why it's dotted, and then it pops out the other side. You can also have line L, which intersects plane N at an infinite amount of points. So since line L is laying on top of plane, so it is on plane N, and a line has an infinite amount of points, then all of those points must be intersecting plane N. Alright, what does it mean to be congruent? So a vocab term that you'll see throughout the year. The term congruent means equal in size and shape, and the symbol for congruent is an equal sign with a little tilde over it. Okay, so if you see this symbol, that means congruent, equal in size and shape. Okay, so let's apply what we learned about two lines intersecting, two planes intersecting, and a line and a plane intersecting. And so we're going to take this picture right here, this cube, okay, and answer these questions. All the vocab terms that we used. All right, are points H, J, K, and L coplanar? So keyword here is coplanar, means they lie on the same plane. So you've got H, J, K, and L. So those are all on top of this. They're all on the top of the cube. So since they're all on that same plane, they are definitely coplanar. So that is a yes. Are W, X, and Y collinear? So collinear means on the same line. So you've got W and X are definitely on this line. And then Y, so Y and X are on the same line. And W and Y are on the same line because you can draw a point through those two. But are all three of these on the same line at the same time? They are not. Okay, so Y would have to be over here, and then a line could be drawn through all of them in order for them to be collinear. Now they are coplanar because these 3 points are all on the bottom plane. Alright, name 3 lines that intersect at X. So here's X. So you need 3 lines that go through that point X. Well, WX would be one of them. That's a line that goes through X. Another line that goes through X would be KX. And the third line that would go through X would be XY. So those 3 lines, okay, would be 3 lines that intersect at X. Alright, are K, H, Z, and Y coplanar? Now this one's a tricky one. Let me show, okay. So most people will look at this and immediately say no. However, let's just connect H to Z and K to Y. Now look at that. You have a diagonal plane going through your cube. Okay, so they actually are all on that same plane. It's just a plane that you don't visually see right away. But if you connected all 4 of those points, they actually do make a diagonal plane. So this is yes. Alright, find the intersection of, alright, so let me erase, oops. Okay, hold on. Alright, we're going to leave that there for now because I'm going to mess something up. Alright, find the intersection of plane WXYZ. So WXYZ, XYZ, so the bottom plane right here, so the bottom of the cube, and line HW. So you're looking at the bottom plane, and you're looking at this line right here. So this vertical line is going down, and it's intersecting this bottom plane at point W. Okay, then you've got, so a point, a line, and a plane intersect at a point, just to clarify. Alright, then you've got plane KHJL, so KHJL, the top of your cube, and you've got plane KXWH, so you've got the left side of your cube. You've got the top of your cube and the left side of your cube. And you're talking about 2 planes. So if you look back at our notes, 2 planes intersect at a line. So you better have a line for this answer. So the top plane intersects the left side of the plane at line KH. Okay, if you put line HK, that would also be okay. Alright, then you've got plane LJZY. So LJZY. LJZY. So the right side of your cube. And line LY. So here's line LY. So that one example we did where you had the line that was on this, so this line LY is actually on this plane that we're looking at. And if you have a line that's on that plane, it's going to intersect at every point on that line. Alright, so the answer to this is going to be line LY. that line, this line right here, is on the right side of the plane. It's on that plane that we're looking at. So all of those points on that line must intersect with that plane. So all of line LY will intersect with plane LJZY. All right, and then you've got line WZ and line XW. So you've got two lines, and if you think about two lines intersecting, they must intersect at a point. So your answer should be a point here. So you've got WZ is right here, and XW, which is right here, and this line right here, and this line right here intersect at point W. All right, last two questions. Name all the lines that are parallel to line KH. So KH, so key term here, parallel. Two lines that have the same slope and don't intersect. All right, so let's draw a green line over KH. So here's KH. Oh, that's not green. All right, so KH is right here. This is the line. So all the lines that are parallel to that. So one line that has the same slope would be LJ. So now look at all the other lines on here and which of these are going the same direction, same slope. YZ is another one, and then WX is your third one. So all of those lines are parallel to KH. All right, let me get rid of those green lines for a second. All right, I'll put this answer back for you. All right, name all the lines that are skewed to KH. So we're still going back. So I'm going to use a different color for this one. Let's use purple. All right, so here's KH again. So now remember, skew means you can't be parallel. So all of these lines that we just named, so this one, and this one are all not skew because they're parallel. You can't be skew and you cannot intersect. So actually what we're going to do is we're going to put a circle on all of, now let's use a triangle, on all the ones that we cannot use. And I'll designate that with a different color. So we'll use blue. Okay, so we can't use this one, that line, this line, or this line, right? Because those are the ones that are parallel to KH. And we have to eliminate the ones that intersect KH because skew means not parallel and not intersecting. So here's your line. So which lines intersect this line right here? Well, HJ intersects at H, so that one's gone. KL intersects at K, right? This line intersects this line at K. XK intersects at K. HW, right? This line intersects there as well. So I think we got all the lines that intersect. So the ones that are left over, okay, you've got JZ, this line right here. So that's not parallel and it doesn't intersect this. You've got LY, okay, again doesn't intersect that line over here and it's not parallel. Then you've also got these two lines down here. You've got WZ and you've got XY. Okay, so those are the four lines that are skew to KH.